In SQL, we have so many joins. Inner joins, outer joins, anti-joins, self-joins, and natural joins. There are so many joins, but all of them need a join condition. Join conditions tell us how to combine two tables into a single table. The first join condition is natural. The second join condition is using. The third join condition is on predicate. First, let's look at the natural join condition. We have two tables. The first table is called player. It has a player ID attribute, a name attribute, and a weight attribute. We also store what those players eat in the eats table. It has a player ID, caloric intake, and frequency of meals. Now, for the natural join condition, we just join the tables based on the attributes of the two tables with the same names. ID is the only attribute with the same name in both tables, so we merge them into one single attribute in our join table. Then we add the unique attributes of the first table and then the unique attributes of the second table. We have one match for the ID of 1, so we will insert in our data for that match, where the unique attributes get data from their specific table, and the common attributes get their value from both tables, which is of course the same value. Then we get two matches for an ID of 2, so we will add the concatenations of those two rows into our join table. There are no matches for a player ID of 3, so it does not get inserted into the join table. Now, let's consider a different case. Notice that there are two attributes matching here, so we must join the table based on ID and name. We will get any empty table after the join, because no players have the same name as any of the food items. We can resolve this by using the using join condition. This join condition works exactly the same as the natural join, except we specify the same named attributes that we want to join by. We can't specify calories or weight, because they don't have a same name attribute in the other table being joined. Let's do a using with ID specified. Then we would get 3 matches with all possible rows that can give a player and one of their eating record. Now, let's get more flexible with our joins. We just use predicates with the on-join condition. If the join condition predicate is true, then the matching rows are concatenated. Please note that we don't merge same-named attributes into the join table, because we are simply joining based on whether a predicate is true or false. If we did a predicate for calories is greater than 200, then we would get 3 matches. We can insert each match in now, where each player matches the row for an apple. If we did a predicate for calories is greater than 200 and player ID equals eats ID, then we would only get 1 match for Jim and the apple. Now, one question that oftentimes comes up is if where and on do the same thing. They don't. The on keyword actually decides what is joined before running where. The where clause filters the result of the join after the joining of the tables. The highlighted rows here are not matched on a join condition using ID, but they can be included using an outer join, which is a special join that includes rows from a table where the row did not meet the join requirement. This can't happen if we try to do the join using a where clause, because it won't be lenient like the outer join. Even if you don't use an outer join, joins are more readable if you use a join condition rather than a where clause. If we run this left join, it includes our unmatched rows from the left table. If we run this left outer join, that includes the unmatched row in the left table, but try to join based on the where clause, that the where clause, which runs after the joins, will remove Jin from our result. Thanks for watching. Hop on SQLguild.com for SQL coding challenges and lessons.